Good day, students. Today, I want to show you how to prove a theorem without any difficulty, with ease. But what we need to do is to study the question appropriately. You don't need to cram. We prove that the angle which an arc of a circle subtends at the center. It's a wire question. Subtend at the center, a circle. Okay. See now, a circle. Subtend at the center O. Okay, call it center O. Is twice that which is subtend at any point remaining part. This remaining point on the circumference. Let's label A, B, C. Let me do some construction. I want to construct this side. Extend it to D. Why did I construct it? Just to simplify the question. We solve this, join them together because we need this. This is center, this angle is 2 times that of the circumference, 2 times this side. That's what they are saying. Okay. Now let's call this one x1, x2, y1. This one is carrying 1. The one at the top is carrying 2, y2. Okay, now let's start with the proof. Given first a circle. You are the one that will draw the statement. Given a circle ABC, you can see it ABC. You can label as ABC. You can label your own with any other alphabet, but you follow the labeling. A circle ABC with center O, and a line drawn through O, the line drawn through O to D, the line drawn to O to D. That's the construction. Okay, can you say construction? Join line BO and project it to D. That's the construction. Join line BO and project it to D. Now the next one is that, let's go to what is the proof? The proof is that AO angle AOC, this angle AOC, angle will be at the center, and AOC, when you are putting angle at the center, means that we are referring to this angle here, equals to this angle, equals to 2 times angle ABC. With the angle at this point is referring to combining these together, x squared and y squared. When you join them together, it will give you angle ABC. Now let's start with the proof. See, now when you write proof, take note, this proof, PROOF, is when you want to carry out the real explanation of your proof. But when you want to tell us what you want us to do, use PROVE. Please take note. Now the real proof will now start. Now line AO equals to line BO. See this sign of line AO equals to line BO. You can see the two, all this point, this line, they are extending from the center of the circle to the circumference. That's why they are equal. Equals to, they are equal. What is the reason? That they are radii. Is that okay? radii. Radius is 1. Since there are 2, we put radii. Also line AO equals to line OC. Okay, let's start with O. Anyhow you write it, but I want to start my own with line OA equals line OB, and also line OA equals to line OC. Okay, radii. I start with O because it's from the center, it moves out. Okay, now what next are we going to do? Because the radius are the same, you can now say x1 radius, this radius is equal to this, they are equal. Is that okay? X1 now will be equal to x2, equals to x2. What's the reason? Because they are both radius, base angle of an isosceles triangle, this symbol of triangle. Now we can now say again that angle AOD, this angle AOD equals x1 plus x2. Let me see, I bring it out like this. This angle is x1, x2. This angle in particular is equals to, let's call it angle A equals to x1 plus x2. If you have a value here to be 20 and a 40 degree, okay, you have to add them together to give you what is outside. Now say equals to x1 plus x2. What's the reason? Exterior angles, exterior angle of a triangle. Is that okay? Exterior, opposite exterior angle, opposite exterior angle. Is that okay? Opposite exterior angle, because this is opposite of the exterior angle. Now, since you have it like that, you now have angle AOD equals, since x1 is equal to x2 here, this angle is isosceles triangle because they are radius. Now you replace it, x2 plus x2 equals to 2x2. Why? Because x1 equals to x2. Okay. Now similarly, we still follow the same suit for this other side. Now you can say y1 equals to y2. That's base angle of isosceles triangle. Call it angles, base angles of an isosceles triangle. Since you have it like that, you now angle COD angle COD equals y1 plus y2, which is the same thing as this other side, which is opposite angle or opposite angles of an isosceles, so of an exterior angle. Or you can say opposite exterior angle. Just write it like that so that it will reduce the statement. Opposite exterior angles. Okay. Now, since you have it like that, your angle COD equals y2 plus y2. What is it? Because y1 equals to y2 because of the base angle of a isosceles triangle. Now angle COD equals y2 plus y2, that's 2y2. Okay, now to get AOC now, angle AOC equals angle AOD plus angle COD, which is equals to, what's angle AOD? That's 2x2 plus COD, that's 2y2. What's common? 2 into x2 plus y2. And therefore angle AOC equals 2 times, what's x2 plus y2? You have to, when you join them together like this, adding them will give you angle ABC. So x2 plus y2 will give you angle ABC times angle ABC. When you finish your proof like this, now say QED. That's Latin word, QED. That's the end of our proof. Very important. You can see we have proved it that the angle which an arc of a circle subtends at the center is AOC. Okay, at the center equals 2 times angle at the circumference, 2 times this. Now if you have something like this, you have 40 and they ask you to look for this x will be 2 times 40 is equal to 80 degrees, and if you have 80 here, you divide it by 2 to give you this at the remaining part of the circumference back. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.